morning, everybody. Here, happy welcome to this opening. My name is Philipp Sinn. I'm the CEO of SINN Power, and today we want to present you our company and our latest products, which we will release to you today. It's the first release we have here on these products. Next to me is Johannes Stuck. Hello, Johannes.
Hello, good morning, everyone. Thank you, Philipp. My name is Johannes Stuck. I'm here in the business development team, and I'm really happy to be hosting this presentation together with Philipp today. The last words in the video, which gave me goosebumps every time I see it, I think the same for you. I hope you liked it too. And we won't stop. And actually, this is probably the key word. We haven't stopped. We have something totally and utterly new, which we're going to present to you today. We just wanted to inform you that we have managed to go very healthy through this pandemic. Philipp and I have both tested negative on a PCR test, which is why we can stand here today and do this presentation for you in a distance of 1.5 meters as suggested by the government. So Philipp, in any case, I would say it's time now.
It's time to start. It would have been nice to all see you in person, but probably we can repeat this in this year or probably next year in Heraklion. Yeah, what we want to present to you today is our ocean hybrid platform. This is a maritime platform in multi-use coming together with our Modtronics. This, what you see here on the picture, is a live picture from Heraklion last summer. And today we are proud to present our first and unique worldwide floating modular ocean hybrid platform to you.
Philipp, thank you. I think before really going into detail, which is probably interesting for everybody listening today, we have to shout out some special thanks, of course, to our team here in Gauting, our team in Heraklion, our partners and advisors. Please do the honors. I think this is also a very important moment for you.
Yeah, we all live from the team. Thanks to our team. I can just admit, Johannes, this was a great job in the last years, also in Gauting and in Heraklion. On the right is the team Gauting, which is next to Munich, and on the left is the team Heraklion in Greece, where we have a lot of Greek friends until today. But our backbone is also our investors and supporters. I would want to point out a few of them, besides others, which is the Schweizer Kapital and Umut Ertan, my personal mentor, Dr. Lothar Stein, the SICK Holding, Protect the Planet, the BMWI and PTJ. They have supported us for many years now, and I'm really glad they have done this. Technical University of Munich and the other Technical University of Munich, we are both supporting us for many years here in specialty, the faculty for power electronics and UTG. And last but not least, our places in Crete, the port of Heraklion. Thank you very much to you guys and all others who have supported us. My professor, Dr. Martin Faustich, and all the others as well. Thank you very much.
Philipp, thank you. So I guess when we look at this slide before we really head into it, this is also a great opportunity maybe for you to explain a little bit how SinPower is set up with the office here in Gauting, then our R&D facility in Greece. Where are the tasks and how does it work?
Yeah, here in Gauting, we have our research and development and prototype testing facilities. So we do a lot of computer-aided engineering here. And in Heraklion, Greece, really close to the airport, we have a real ocean location where we can test our equipments directly in the ocean. And we're doing this since 2015 in Heraklion. So we had a continuous interruption of developing, testing in live situations in Heraklion and then improving here again. And now we are proud to present you our latest and market-ready solutions of ocean hybrid platform and Modtronics, which is not the case for many other people, where you might only see some visions and designs. But now I think we will also show you some visions.
All right, let's do it. Exciting moment.
Yeah, what you see here is more or less the base situation of our hybrid platform. We have developed power plant, a floating power plant, which is able to produce electricity out of ocean waves, out of solar radiation power, PV, and small wind farms, all combined on the same platform and all connected with the same electronic smart grid system. And in the back end on the right, you can see it's also used for platform facilities. So this is a real ocean designed solution, which is designed for harsh environments, strong waves, and strong winds.
Philipp, obviously, a really cool thing here, the combination of multiple renewable energies, which gives you the opportunity to really customize the technological layout of the platform according to the climate conditions. So if you go into regions where probably there is a lot of sun, but not so much wave or wind energy potential, you would primarily put PV modules on. However, if you go to regions with a lot of wind and wave, you could customize this and increase the share of wave and wind energy.
Yeah, exactly. A little bit more you will learn about this in the presentation. We also have storage systems, etc. But this is the base. We can adjust in size and in combination of renewable energies. We can adjust to the location and the requirements of the customers.
All right.
So Johannes, I think this is something you like most.
Yes, I like this very much. Not only the setting with the snowy mountains, which we unfortunately also have, but we cannot use them to go skiing this year, which is a pity. But no, let's get back to the OHP. So here, what we have is a multifunctional modular platform approach where we combine renewable energies with a processing platform, giving infrastructure for a circular economy, for example, of an aquaculture as depicted here in this picture. As you can see, we can kind of show the entire process of an aquaculture from the larvae tanks, which you can see on the left, up to the ocean water tanks, which are on the back right. And then we also have small houses for processing the fish. And then obviously you could also dock with a small boat or even a larger boat to bring this processed fish then to the land. Please note also in yellow the cranes that we have on here, which allows and facilitates moving the processed goods on the platform. So it's a really holistic approach here. Obviously, Philipp, we are not experts for aquaculture, but this is one vision that we have. We want to bring processing and infrastructure to the sea.
Yeah, and obviously we want to do this all with a sustainable hint and feeding all this sustainable and on a floating, really slow impact solution.
Vision number 3, in very much contrast to the picture before. Here it's nice and warm.
Yeah, this is actually something we are coming from. We wanted to supply islands with electricity. You all know that all these small islands around the world still run on diesel. So first of all, we want to supply them with clean, renewable energy. There's a lot of energy potential in the ocean, but there's no space and no big cranes and facilities available. So this is one goal. But the other one is, if you have large regions with small islands, you might want to distribute your goods and you have a central capital somewhere which is far away. So you might want to have distribution hubs, and our platform could be used as an artificial island for industrial use. So for industrial distribution of goods and then powering itself with its own electricity. So you have stocks there where you can hold goods, you can dock with a boat and you can distribute your goods even if your main capital and the big ports are far away.
Yeah, I think the real benefit here, as we will also see on the next one, we're really talking about using the OHP to overcome scarcity of land, being it in island regions or in coastal regions, big coastal cities as we have them all over the world. And this is also what we can see here.
Yeah, another attempt. So the core issue is the renewable electrical energy production. But here you find a mega city as we know them all around the world, from Hong Kong to Barcelona. These are big cities where the land price and the land use is all stuffed So you might need to bring logistical centers into the city centers, which is not possible because there's no land anymore. You might need to have a server farm which provides additional computing power also close to the city. You might need to produce hydrogen to fuel all these electrical cars which are developing at the moment in the future with clean and green hydrogen. What do you do? How do you bring all this into the city centers? If these cities, and maybe 80% of the large cities are at coastal areas, and the seaside is not used. So if you bring our platform there, you can bring this renewable and technical hub close to the city centers and do all this. Calculation centers, server farms, hydrogen production, and logistic, all possible on our platform.
So now the last vision we'll be showing you, it's a lot of input obviously, but this is really the core of SinPower's development. This is also the reason why the German federal government decided to help us on our way to finance us partially. Philipp, please explain what we can see here.
Yeah, you all know the wind farms in the northern and eastern sea, and we have them around the world. And these are mega big farms. They are quite far away from the shoreland, and they have a big cable coming to the shore. And it's always the question, how do they work? In the winter times, they produce a lot of energy. In the summer times, because there's not so much wind, they produce less. So to provide a more continuous power supply and optimize all these fields which are captured for electrical production in the ocean, we suggest to integrate our ocean hybrid platform with solar and wave power, because this is this adds on to the given wind production mills which are there, and therefore you can optimize the overall field, you can optimize the annual output to a much better continuity. And we have done some studies in terms of the cost. On our calculations, we could at least triple the cost of the power installed investment per kilowatt peak or per megawatt peak, whatever you want, by on the same time increasing the produced energy amount by almost a factor of 10 on a given field. I don't know if you want to do that, take 10 times as much energy out of the same area, but it is possible because it's a much higher density in our platforms than you will find in such farms.
Yes, just to make it clear, you said triple the cost. Of course, you mean cut the cost down to a third.
Sorry.
Yes. Just so.
Yeah.
Just to correct this.
Cut down the cost per megawatt peak by a third.
Exactly.
Sorry about that.
Okay. Yeah. So now we've showed you a lot of the opportunities that we think can arise with the OHP. Obviously, we do not know all the cases, and probably there are cases that we haven't thought about that while you are watching now may already have in mind. We'd be really glad to hear these and to talk about these with you later on. But now we have seen this modularity, this flexibility, versatility. Let's look a little bit into the engineering behind this technology. Obviously, we are now breaking it down into the main assembly groups, the structure fences and the floating bodies. But there is a lot of much more detail in the small parts, but we will not go into too much detail. It would take too long. But I think what we'll show you now will basically cover the fundamental principle and show the ease of installation and handling that comes with the OHP.
Yeah, Johannes, let's go on. Maybe we can explain the first parts. We have been trying and re-engineering our structure a lot of times to optimize and simplify the solution. In the end of the day, it looks super simple and trivial, but coming to this point needs a lot of engineering. It has to restrain big waves and storms in the ocean. It has to be easy to be easy manufactured, easy build and everything. So this all, it comes into this product, which in the end looks trivial and easy. But here it is. We start with the structure fences. They come with pressure pipes. You see them in blue on the top. They are in a length of 6 to 12 meters, so fairly long actually. We are talking about big pieces here, but they are not so heavy. So we're talking about 300 to 370 kilo each. This, you cannot handle this by yourself, but being a few people, you could even lift it, or having small forklifts, you can use that. So we have been looking that we don't get too big parts, so we can install that wherever we want. The vertical struts, the same, they are much lighter and they are 6 meters high, and the pull rod. So in the end of the day, we construct a structural fence, which is super stiff, which is made out of maritime aluminum and without any problems in corrosion and durable.
At this point, Philipp, there's two important things to add. One of them being, of course, that these pressure pipes are welded, they are sealed, which means that they can float. This is one important aspect. So they already have their own buoyancy. And the second thing that I would like to talk about, because this is a question that I get asked almost every time we talk about the OHP, what about corrosion?
Yeah, I have given that for short. We have found that the corrosion is solved best, and we don't have problems anymore since 2015 actually. In the beginning there was, but now we found a really good maritime aluminum with small connection pipes of stainless steel. So you have a really durable and robust salt waterproof solution.
So to cut a long story short, we don't have problems with corrosion.
No.
Perfect. All right, now let's move on to the second main assembly group, which you can see here are our floating bodies, obviously also following the same modular approach, easy to handle, not too heavy, can be fitted into containers for shipping and stuff like that. What is special about these floating bodies?
Yeah, as well as most of our products, we have patents because on that, because all of our products are new and we have approaching a new market. And the speciality about this floating body is this floating body gets the whole force of the waves. It's the first interaction with the waves and the environment of the water, and this has to be super durable, super stiff, super hard. And the solution here we found is a polyethylene solution, which is designed like a cake. So you have many small pieces, you see them on the top picture, which come together in a connection hub in the middle, which is made out of a strong metal. You bring them together and you put a belt around so it cannot fall apart anymore. And that's it. It's super simple. It's relatively small and lightweight parts each. And then you can design a floating body of a lifting capacity of 6 tons with a diameter of 3.2 meters and a height of 1.4 meters. That's quite amazing.
Absolutely. So now when we put the structure fences and the floating bodies together, what do we get?
Yeah, bringing 4 of these fences together, adding 4 of these floating bodies, you get the smallest floating unit. So that's what you see here in the front, and from there you can go on. You can go in either one direction or in both directions, and can increase your platform to any size you want. And therefore you're super flexible in the dimensioning, and obviously you can design any large floating platforms starting with small parts. This is not possible until now. Any big platforms in the world, they need big ports, big cranes, and then they can be designed.
Perfect. I think we have a demonstration video on the installation that we will show you later on in this presentation. But now obviously we have shown you how the technology, when assembled, works and how this modularity and flexibility can be brought into the OHP system. What you saw in the visions before, obviously, is much more the use cases that are accompanied by this technology. And it's important for us to give you a better understanding of the customization opportunities that come with the OHP in order to make these different use cases possible.
So we can vary a little bit in the designs. Everything is designed to be modular, to be easy to build. And what you see here is on the left side a dimensioning. You can change between a distance of 6 to 12 meters in each of these squares. Why would you do that? Because when you have stronger forces, especially for carrying heavy weights on top of this platform, you might want to have a smaller distance between each knot. And it's possible only by changing the length of these pipes. All the connection points and etc. they are exactly the same as they will be before. On top of that, we can vary the buoyancy on each knot by 6 tons. Each floating body has a buoyancy of 6 tons upwards, and you can add to each knot up to 18 tons of buoyancy. That makes a lot if you calculate it in a square.
Absolutely. All right, so now we've learned about all the technical stuff, but now it's also really important to talk about the renewable energy integration. And I want to start off here, Philipp, with the wave energy integration, since this is also where SinPower initiates. And I think it will be really simple to explain, because it's such a simple principle how it works.
Yeah, I hope it's simple, but I think it's simple. Yeah, imagine you have a given platform and not every knot is connected with a floating body here in the side, the black floating body now, to get a better understanding. So the platform is given, some of these floating bodies in some of the knots are installed. They are actually installed without vertical movement, so they're fixed to this platform. Then you go with a lifting rod in red, you come from the bottom and push this lifting rod into the center of this knot and connect from the outside the floating body. So the floating body is separated in parts, so you can install it after you have installed the platform itself and connect it then with this lifting rod in the middle. This gives a flexible floating body which can go up and down with the wave, which is connected to the lifting rod. So when this goes up and down with the wave, the lifting rod goes up and down. And on the top, we put our Modtronic powertrains, which are computer-controlled electrical machines, which then run with the movement of the vertical rod up and down and produce the electricity in the wave power module. That's as easy as it is, and it's really not much more than you can see here.
So basically, if you have an existing installed platform, you could at each knot point integrate wave energy converters by adding 3 simple components: the powertrains, the floating body, and the lifting rod.
Exactly. You can do this afterwards. You can do this directly whenever you want.
Okay. Now, the second solution, which shares a lot of components with the wave energy, is the wind energy solution. Philipp, please explain.
So having the same platform again, you use the knot, this time not for wave power. You have to decide. Either you can use wave power at a given knot, or you can install wind power. But we use the same mast. The pipe, which is running up and down in the wave power device, can be fixed to this knot, so it goes above the platform, and there we can install a standard windmill. We have a special windmill here. This is a cooperation development with our partner and friends Lufside, which also live here close in Munich. And they have designed a super nice windmill, which is storm resistant and can still run in storms and uses the same power electronics we use all around our systems. That's the Modtronic powertrain.
Which we will also explain in one of the further slides. But just to resume, the powertrain is the same and the mast is the same. So 2/3 of the system for wave and wind seems to be the same.
Yeah, and especially we can use it and easily integrate it in our platform. That's a big advantage.
And now, of course, last but not least, we also have a solution to install PV on our OHP. Obviously, this was something that was clear that if you have a large surface that you're already providing, it absolutely makes sense to install the sophisticated technology here. Philipp, I think the really crucial aspect here are the traverses, which are able to withstand these forces. So please explain a little bit.
Yeah, we have developed lightweight traverses which have a length of 12 meters and only weight 130 kilo and carry 1,000 kilo per meter. That's quite a lot for this band of distance. So we place these traverses in the same distance of the length of the PV modules, one to the other, and then we just put PV modules on top. We can vary the angle by installing these traverses on a different level, and then in the end you have a PV plant on top of your platform. A big difference, which you should never compare, are inland water floating solar systems, which are coming as carpets. So these are flexible systems laying on the water, and when there are waves, they bend with the waves. We have designed a super stiff and robust wave resistant platform, which does not bend, or it bends obviously a little bit, but it doesn't bend with the waves over the length, and it has a high distance to the water surface. This allows to run this solar platform even in big waves, 6 meters breaking waves and higher waves in the ocean. And by the same time, this distance dramatically reduces the salt spray on the PV modules, which would decrease the power output. We have tested this, that if you go just maybe a meter above sea level, you will have a strong salt level on your PV modules, whereas when you go 5 meters above, there's almost nothing, and the rain will wash it away. So it's no real, we have compared this to land-based solar systems, and it's more or less the same dust and stuff on this plates over time as you see on land systems.
So to resume, the OHP, with its structural integrity and being designed for wave energy conversion, is basically the only solution to bring photovoltaics into offshore wind parks, because it's the only platform that will withstand the wind forces, the wave forces that arise in these areas.
At least until today.
At this point, we would also like to thank our partner Schmidt Peckintash, who have provided the PV modules for our platform in Heraklion that you have seen in the initial picture. Here we were working with 72 cell modules. We are almost at 30 kilowatt peak on this given surface of 144 square meters. And Schmidt Peckintash had some prior experience with PV modules in coastal areas, and have made some special adjustments to the backsheet and also to the junction box, so that now equal to our Modtronics has an IP68 rating. So thank you also.
And saltwater resistant,
of course.
Yeah.
So the same principle for what we use in the PV to house the modules, or to have the modules on the platform, we can also use to put on solid floors, which obviously, if you have this amount of infrastructure or installed capacity, you require some of the fields to not be reserved for renewable energy production, but much more for electronics or for the other infrastructure that we have shown.
Yeah, the industrial island, as we call it, to put infrastructure or any operation facilities onto it. And because we can change the distance of these traverses, and they have by itself a quite big carriage which they can carry, we can bring up to 1,000 kilograms per meter, which then, if you go in a distance meter by meter, which means you can bring up to 1,000 kilogram per square meter onto our platform. This is quite amazing. This is quite a lot. This is more than you have in a typical house for the flooring, actually. Cool. So you can really build really strong and stiff, solid floorings for infrastructure use on this platform.
Obviously, we do not manufacture the floor itself, but we have already made some cooperations here, and there's a set of different floors available depending on the use case and depending on the loads that have to be carried, but they meet the substructure at this point. All right, so now the OHP, we've shown the use cases, we have talked about how it's installed, how it's set up, what are the main components, we've talked about the renewable energy solutions. But there's one really important thing we haven't talked about, and that's how does the OHP stay where it's supposed to be? Yeah,
we have decided to go modular again. because it just makes sense. If you want to go from small ocean hybrid platforms to big ocean hybrid platforms, you don't always want to design a specific anchoring. And especially when it goes big, then you would need enormous big anchors. So what we do instead is to have a multiple anchor. This has many advantages. First of all, it's more or less standardized. The prices are much cheaper for the overall anchoring. But second, it's easier to bring it there and to install it there. And last but not least, it has a much higher security, because if even a single or two or three of these anchors would break, all the others would still hold the overall platform. So we think this is the best approach to go for this anchoring, to go for multi-anchoring here.
Perfect. So now that we've talked about the mooring, anchoring, let's talk a little bit about logistics, because all of the engineering and design and all the thought that went into it also had a lot to do with how can we transport the OHP all around the world, and how will it be able to be installed and handled easily?
Yeah, I mean, no matter if you are in Heraklion having big facilities in ports, or in other big ports in the world, or going to a rural area in the world, it is important to make transportation and logistics and facilities easy to be installed. And this was one of the main focuses and goals in the development of this OHP, that we can transport all our parts in given transportation systems. So we don't need specific transportations. We can put this into containers, we can put this into typical trucks which you see every day on your highways, and then we can bring it to any location in the world. There we can install it with really easy equipment. We don't need super large cranes, etc. And this brings also another point into focus, that the procurement, where we get our goods. Only a few of the smaller parts we produce ourselves in the power electronics, but the bigger parts, we're obviously not specialized in producing big pipes, etc. So we have a procurement all over Europe. The pipes come from Italy, the floating bodies, they come from northern Germany. Some parts come from Poland, others come from Brussels. So we have a European-wide procurement, which we then bring together for the projects. And obviously, when we are far away, we could also think about procuring the pipes, for instance, in India, when we produce a power plant in the Maldives. This dramatically would improve the carbon footprint and reduce the cost of logistics.
So now you've already talked a little bit about installation aspects. We have prepared for you today two videos. One is a land-based installation, which we actually did in Heraklion. Here we have a time-lapse video that will show you the process of the entire installation process. And then we have a simulated video for our patented floating installation system, where the entire OHP can also be set up on the water. I will now change the screen so that you can see these videos.
So it was the installation in Heraklion last summer. Thanks to our team there. This was quite a bit of work because it was all new, and but it worked out really well actually. And this was how you can build it when you have a big port. It's obviously easier when you do it on the land side, because you don't need to work from boats and smaller platforms to install this. But we can install the overall platform, and this is also integrated and detailed designed and also explained actually in a patent, how we can install the overall platform when there's no port given and when there's no big machinery given. And this is actually a quite tricky part, but it also works. So what you see here are two fences. They we built them lying horizontally on the water. You can do this in really shallow water. You get these big pressure pipes. They are sealed there, so no water can go into it, and they float itself horizontally. Everything is designed that it can be installed super easily when it's horizontally, and you don't have screws and nuts. So it's a self-finding connection where you only put a bolt into it in the end, and then it's the fence. So when you have these fences, two fences built in shallow water, you bring them to deeper water, and then there you flood the lower pressure pipe of both. There is a solution how to flood them. You will have some flexible pipes to the top, and you can flood these pipes so they sink down until they're vertically in the water. When they are vertically in the water, you connect them and then press air into this platform again. So the whole triangle comes up to the water surface. The floating of the lower pipe is strong enough to carry the overall platform. So when you've connected it on the top, you don't have to dive. You just connect it on the top. It's obviously not stable then. It's only a loose connection, but it has a small stability, and then it comes up, and then you come with another third, and that's the first piece. Obviously, from there you can imagine how to grow this platform bigger and bigger. You come with fences, go from horizontally, vertically, take another fence, go from horizontally, vertically, connect them, lift them up to the surface and connect them to the given structure. And in this way, you can install it anywhere in the world really easily. So going on, you see now how we install the floating bodies. You have the internal connecting, strong connecting pieces, and from the outside, you bring the floating bodies. And then when you have that, the whole platform is lowered down to its final position of floating. The lower pipes here, what you see here is the installation of the solar system. But another interesting point is that with this pipe system on the below water level, you can also use this later for cooling. When you have a server farm, you can take the same pipes which you used earlier for installation by pumping in hot water on the one side, going through the ocean and going up again. And you have a super robust and maritime heat exchange system at this point. So when it comes to operations, you can also use the same facilities, not only for installation, but also for cooling of any heat source.
Great, Philipp. Thank you for explaining a little bit on these videos. Let's jump back into our presentation. So, I mean,
Johannes,
we've talked so much now about the use cases, how it works, how it's installed, how to transport it. Let's just sum up really quickly what we've learned so far. The OHP, it's really versatile. It can be customized in layout and set up to meet kind of every application or process that you can imagine on DC. It's easy to handle. The components are rather lightweight. The dimensions are designed to fit into standard shipping and logistics solutions. So also on this aspect, we have put a lot of thought into it. The components are extremely durable. Obviously, there's no point in designing or constructing anything that will not survive in the environment that it's meant for. And it's very efficient, not only because We have put a lot of thought into it, but also because this modular approach allows for a large repetition or a high repetition of the components, which immediately goes into extreme economies of scale.
Yeah, I fully agree, Johannes. Thank you really much. I think now we have to ask you to go to the next topic, because the platform itself is a plain mechanical issue. So how do we do this renewable energies?
Yeah, of course. And now maybe this is the part where it becomes a bit more complicated to understand, because now we're going into bits and pieces of electrical engineering, which is also one of the main focal points of SinPower since a couple of years. And as you already said, Philipp, when building these OHPs with different renewable energy sources, you really have to need an electrical solution to build these smart and complex networks that will withstand in this maritime environment. Because if you obviously take standard components that you could find on the market, they will probably not last very long in this harsh environment. So now what do we have? We have Modtronic. Modtronic is an acronym for Modular Power Electronics. It's a holistic product portfolio covering electric machines, power electronics, storage, and various power-ups that allow a customization to the use case that we're looking at. Philipp, we have here some USPs of the Modtronic. Please go a little bit more into detail.
Yeah, it's designed for the ocean. It's a smart grid system from the electrical machine into the grid. So going from left to right, you see our electrical machines, which are which we share with, for instance, the windmills. Our power electronics, you need power electronics to shift voltage and current levels from one to each other. Otherwise, you couldn't combine them. And the electricity you get out of your plug in your houses is obviously not the same as you find outside in the fields when you have all these lines there. It's in between, you always have to shift up and down. So this is this family. We have a family of storage solutions, and we have a family of power ups and PLC control. This comes all in the same framework, as you see, of the maritime aluminum case, and allows to avoid even switch cabinets, because we even have the overall control included here. So all this facile and small power electronics is sealed and covered in this equipment, and they can even be used in deserts, in the sea, inside the sea, underwater, even if you want.
All right. So now on this slide, we've taken the example of the small wind turbine we developed with Lucide, just to give you an idea of how the Modtronic system works. Here internally, we call it electrician's Lego, because it's a plug-and-play principle and it's really flexible. So in order to have a 10 kilowatt peak power train inside the wind turbine, we can connect two electric machines. As you can see, the second one also has the shaft which goes into the first electric machine. We have two motor drives which are active pulse width modulation controls, and then we have a junction box which handles the entire cabling, and we seal it with a lid. And what do we get? An IP68 10 kilowatt peak fully controlled powertrain that is now able to deliver the electricity of this offshore wind turbine.
I think, Johannes, how about all these wirings? I don't see any of them. What is the case here?
Yeah, so within the system, we have a backplane where we transport different voltages, all the currents, and of course also the communication signals. We can fully integrate with existing systems. We have an OPCUA connection point. So we're really at a state-of-the-art industry standard here with these components. Full flexibility, go ahead.
So summing this up, we have different modules. You can put them together. This is a sample of how you can put them together. And when you connect them, they're not only mechanically connected, but also electrically and on the communication side. Is that correct?
Exactly.
Okay. Yeah. Pretty cool. Yeah. Here, some samples out of many possibilities you can adjust Modtronics to each other is here the powertrain again. This is a smaller version, which you can see on the top side. It's a single machine with 5 kilowatt. Then you have a DC converter with 20 kilowatt. This can be used for solar fields. So you run the solar fields with that. You can charge batteries and super cups, and you can decharge. All our solutions are bidirectional, so you can go in and out with the electricity. On the bottom left side, you see a sample of a 20 kilowatt inverter. This inverter allows 3-phase and asymmetric power supply. So each phase can be fully powered without powering the others. This is really special. It can be can power directly into the grid, and it can power. It can build its grid by itself. So it's off-grid and on-grid, in off-grid and on-grid use. On the right side, on the top, you see an LFP, lithium ferrite storage solution, together with its power electronics. So we always have the power electronics not in the switch cabinet. We have it integrated directly at the point where it's needed. The super cap solution, and last but not least, the PLC control, which is the interface to us, because then we can have a picture on our computer and see all the power plant which is assembled.
Philipp, the process of connecting various modules and increasing, for example, the rated power of powertrains or the rated power of inverters, of course, this also counts for the storage solutions, where we can combine multiple of these LFP units behind each other and therefore increase the installed storage capacity of one single LFP storage string up to 30 kilowatt hours. So also here, full flexibility given.
Yeah, and then obviously from 30 you go to another string and you can go to megawatt hours, but yeah, this is how it works. All the modules can be increased or decreased in size, and then you can enlarge them in putting them parallel, and that's what I think you want to show here.
You're always a step ahead, as always. So what we showed you before are unit examples. These can be used, for example, as regular inverters, as you know them, for your homes or for the application in a wind turbine. Obviously, when you look at the OHP use cases that we have showed you before, we're talking about really large, complex networks, electrical networks, and it makes absolute sense to bring the Modtronics components together into one place to make sure that also for operations and service and maintenance, you have a single access point where to reach out and where to do these works. And therefore, we have developed the SINN Power Cube, which basically is an IP68 SinPower development of a switch cabinet. It brings together various of these Modtronics modules, and it's what we define as our network solution. We can combine different renewable energy sources through the power cubes. We can integrate long and short term. So we could, example, have one power cube just with storage units. We have one with inverters next to it. And obviously it also functions as a grid connection point. And also very important, Philipp, in the power cube in the bottom, we can integrate transformers to go to a high voltage connection if we have to cope with larger distances from the OHP to the grid connection.
Yeah, so going from small pieces which are handleable to large systems, and that's what we want to show you here, how this in principle works, really broad and really rough. We can use this Modtronics. Imagine each of this picture is a system, is a string of these modules fit together. You can go either on the ocean or you can go on the land side. The smart grid obviously is independent of ocean or land side. You can go even below, dig this system into the ground. So for instance, when it gets hot in the summer, you don't need to go for this derating, which you typically need to do with power electronics, because you're still in the cool air because you're 1 or 2 meters below surface. But then when you have this supply given of wind, solar, or wave technology, or anything alike on the land side, we all bring these components together by our power electronics and controlled to an 800-volt bus. And this 800-volt bus is our base to distribute the electricity from supply to the demand and backwards. It's a bidirectional system, and you can add as many pieces to the system as you want. So here, saying land side, ocean side, you could feed a couple of houses, and in the end go which are off grid, yeah, doing its own network, doing its own 50 hertz, and then in parallel have a feed in on another place. So that's more or less the full flexibility, which we also need on our platform, because we have different sizes. We always need the same, use the same solutions to go for wind, wave, and solar, and for the supply side when we want to feed a cooling house or a hydrogen plant, as we were planning to do now in the Canarian Islands.
So basically, we're talking smart prosumer grids.
Exactly.
Producers and consumers.
Yeah, I think that's now for the theory. This is actually what we have in Heraklion. We have, you can see on our website the pictures from Modtronic, from our wave power devices, from our platform in Heraklion. Please feel free to have a look here. But to understand the principle, how it is connected there, we have shown this in a really simple way to use. So we have the wind mills, we have the power trains for DC converters for PV, we have the grid inverters, and this is all combined on this 800-volt bus feeding into our system. And that's what we have there. We have a system size of a few hundred kilowatts, and this is spread more or less over half of the port of Heraklion, having a wind turbine here, having the wave power plant there, having the solar plant there, and all combined in this platform. And we have access from gouting to this plant, seeing if everything is okay.
Perfect. All right, Philipp, I think for now, thank you very much. We will now change a little bit the topic, because it's been quite a lot of information that we've given to you up to now. And we thought, how can we further facilitate not only the planning, but also the execution of these types of projects? When you have a modular structure and a modular electronic system, you obviously need some sort of tool that helps you to combine these. And so I would like to welcome now my colleague,
hi,
Christopher. I have a
Hello.
picture of you on the next slide. You're wearing a mask, obviously, so but everybody will know what you actually look like.
Yeah, hopefully.
Before we start, we have a input-based configurator that then gives you layouts. Is that correct?
Exactly. So we want to reduce the complexity that would come if you want to design large systems with multiple of part groups, and also difficulties maybe due to layouting. First, we had done this all by hand, realizing that it takes too much time. We just want to satisfy the needs and the demands and questions from interested parties. And therefore now we have a tool developed that enables us to, in few minutes, by few clicks, to generate large systems.
So initially, I remember we had some interest here, and I came to you and I said, listen, we have to kind of lay out this platform for this customer. And I remember it took like a week to put all this information together.
Yeah.
And now, I mean, whenever we have a lead, I come to you, and after 30 minutes, you come back to me, and the project is almost done, which is really amazing. So let's have a look how this works now. Here again, you can see what Christopher normally looks like. So in order to show you how the configurator works, we have decided to build a little showcase, which shall be placed in Heraklion at our R&D facility. It's an OHP size 72 × 72 meters, which is 6 by 6 units. 35 of these units shall be installed with PV power, one of them as a structure, as a floor to install the 2 MWh of storage that I've added. We have 4 wind turbines, 4 wave energy converters, and of course, you want to feed into the grid, maybe 1 megawatt peak, 3-phase, 400-volt AC.
Great, yeah.
Okay, so let me pull up the configuration tool for you. The stage is all yours.
Thank you for the mouse. So we have 2 configurators. one being for the electrical one and one for the platform. Here right now we want to start with the platform. I think the demands were 6 by 6.
6 by 6.
Okay, let's quickly type this in or just click it. It's very easy. And so for the purpose of this demonstration, usually you would just like generate it by typing it in on the right hand side. But now we're just going to generate it by hand. This was the first approach that we use. It still takes up a few more of seconds, but you can still generate the system. As you can see on the bottom here, we have a large system now. It's a 3 by 4, so 12 squares. And now you have multiple parts that you can use. If you have the structure now, I thought we also want to integrate some wind power.
Yep, let's go ahead. So by clicking the knob points, you can decide whether it's a wave or a wind installation.
Exactly.
So now we have 3 red dots, which is the small wind. By double clicking, we get orange, which is wave.
And then we could
recalculate this.
Recalculate it. And we see it on the bottom actually here.
Yeah. So now, really, so what's really interesting, Zäune is the German word for fences, and Schwimmkörper is the floating bodies, and you can see that we immediately get an idea of the amount of different assembly groups that will be installed in this platform. Obviously, on the bottom here, also small wind turbines, wave energy converters, and the PV setups. On the right side, you will get a first indication of this entire installation regarding the installed power of the different energy sources that you have, and obviously the surface that this installation will take up.
Yeah. So let's see whether on Windows we can go into the electrical.
So now we've looked at the mechanical aspects, the platform itself, and now we will transfer this information on the electrical side to understand how this system shall look like.
Yes, but the key is not working right now. So I think we have a problem with the Windows here. I would just like send the video afterwards on the website, and therefore we can see with the configuration for the electrical parts, it's opening some other windows. So therefore I would reschedule this. Thank you.
All right, thank you, Chris. In any case, if you want to get in touch, you have an idea for any project in mind, Chris and myself, we will be happy to assist you with this project, and you will find our contact details on the website, and also we will share them with you at the end.
Maybe I want to add something to this. Why did we show this to you? Because it is an internal tool which we use and which we're happy to share with partners in a later stage. But normally when you plan these big projects, it will take you a week, and it will be a tremendously high bill of materials and list of parts which you require. And we have automated this. So you can do this by really short clicking around and defining the overall project, and it gives you the full bill of materials required for this project in the first step. Obviously, overall project needs a little bit more. You need to go on stage, see how deep is the water, etc., go for licensing. But to get a general idea and adjust all this flexibility to the customer's need, to the demand need, this is a really, really good and helpful tool which reduces the time for this pre-processing and pre-planning dramatically.
Yeah. Let's go back into full screen here. All right. Obviously, it also cuts a lot of the time that I spend with doing this and Chris. So it's a really big help for everyone. So now let's come a little bit here to the end. Obviously, it's really important not only to share our technology, but also the scope of our works, of our services. And as we have developed all of this technology, we are happy to be alongside our customers and our partners the entire way. So we have the highly skilled engineers here for project layouts. Obviously, we have set up a supply chain, so procurement is within our scope, and we can supervise any type of construction since we have already installed our demonstration projects. So we're really along here with all the way. Obviously, initial operations up to the transfer of the plant is also something that we are happy to do. and SinPower as a main supplier of the major components within these OHPs will be able to offer service contracts for O&M, and we will cover from the very beginning to the very end. We will be your partner alongside, and we're really looking forward to getting in touch with you to make sure that your vision of the OHP or smart grid applications with Modtronic become reality.
Yeah, I think there's not much more to say to this. I must thank you really much for attending here. I hope you are fascinated as much as we are from our ocean renewable energy solution. Really a way to go into the future and change the world to a better and more renewable situation. Thank you very much for listening. Thank you very much, Johannes, for this immense work you have put into this project as well, besides all the others. And now I think we are open for discussion and questions, if you have any of them.
Thank you to you too, Philip. Thank you, Chris. Thank you to the entire SinPower team. Thank you to our partners, suppliers, customers. It's been a great journey so far, and we're really looking forward to everything that will come up in the future. And now I already see that we have here some questions and answers. Well, we have questions, and now we will provide the answers. So Philip, I will be the moderator for this, and I guess you'll be the one to answer. The first question comes from Raul Cascajo. How would the system behave in harsh sea conditions, for example, open sea waters?
Yeah, therefore you have to know about the behavior of waves in open sea. So when you come near shore, they start to break, and you have got this washing machine. And for these surfing waves, as you can call them, which break over, we have an approximately wave height of up to 6 meters until it's safe. For the offshore wave, this is a totally different issue. They, even if they're 10 or 15 meters high, they're super long. That means that our entire platform goes up and down with these waves when you go to offshore waves, and there it has to be determined specifically on the project side, but it can go for much higher waves, and 10 meters shouldn't be a problem here.
All right, next question, also from Raul. Have you estimated the O&M costs?
Operations and maintenance. We have estimated them. We are planning a large project together with some of the biggest industrial partners in Europe in the Canary Islands that produce renewable hydrogen. And there we had to estimate these costs. It's an estimation, but we are thinking of, I think, 5% of the installation cost per year. Is it?
But this is for the entire system. So we think that in our technology, since it's a very simple approach, there should actually be hardly any O&M, and the O&M mainly is involved with making sure that the service intervals on the electric side are met. So we would basically look at O&M costs lower than 2%.
Okay. There you're more into this detail, but what I can say on this point is that all parts are designed to be that you can change them even when the whole rest of the platform and the electrical system is running. So you can dismantle any piece of the platform within the platform itself. That's not trivial. That's really complicated and a really specific part of our ocean hybrid platform. And the same you have on the Modtronics. You can do this hot swapping. That means while still the overall system is running, you can take out a broken part and put it in again by just plug and play without a lot of wiring, etc.
Okay. Next question, Samir Savara, will you discuss the cost for these structures? Samir, so obviously you have seen the great flexibility and versatility in the system. Also with the planning tool of Chris, we have all the prices within our ERP system, but it highly depends to give a final price of a project, since you have a lot of variable costs, which might include, for example, logistics, installation, and the mooring system, which depends also on the depth of the water where it's installed. So if you have any project in mind, please feel free to get in touch, and we'll be able to provide you with a specific price for your project. In any case, I can tell you it will be somewhat competitive to existing solutions that you might have looked at before.
An interesting point here I want to add is when you go to only for the platform, because the renewable energy system strongly depends on the combination, as Johannes said. It's not, you cannot just say this and that. We are competitive, that's what we know. But when you look only at the platform and look at the price per square meter on the platform, we know that we are by far more cost efficient and cheaper per square meter than you would have on a city industrial ground, where you could place it in front of.
All right. The next question again from Raul. Which would be the size of the basic structure and the floater? Could they be customized in size or just scalable? So the components that we have showed you are not adjustable in size. We try to build OHPs in different designs and layouts with these given components, as we have showed to you in the structure fences and the floating bodies. I think the first part of your question came before we showed that slide, so I think everything is said here. If you think the question is not answered, please feel free to write us an email and we will come back to this. Next question, Simon Stark. Which wave climate, HS in extreme condition, HS max, is the OHP suitable for?
I think we have answered this question before.
Yeah, so this was 6-meter breaking waves and a lot higher in the open sea. Maybe just as a quick explanation, typically when waves get very high, they also get very long in the open sea when they're not breaking. And this is basically why it's not really a problem to cope with large waves. Will the webinar recording be available after the session? Of course. Oh, and now we have a lot of questions from Parshant Kalbra.
Maybe let's go for a really specific one.
What is the cost of setting up such platform? As I said before, this is project specific. Please feel free to contact us for the idea you have in mind. What is criteria for evaluating feasibility of OHP deployment, both for wave and solar PV generation? So basically, what we would need is to get geographical coordinates, and then Chris would have a look at the different renewable energy potentials at this point, and then you would kind of decide, you're looking at continuity, so baseload capacity, or do you only want to install PV, for example. This really depends also on the demand of the project.
The lifetime of the project, yeah, it's designed obviously for long-lasting lifetime of 20 years and more. Then what is the cost saving benefit offsetting to land? This is dependent of the opportunity cost of land. When you have got the land for free, possibly you might have a better solution for to go on the land. But in many cases, when you go to rural areas, to islands, etc., that's really difficult. You have mountains reaching up from the ocean, and there you cannot install easily any renewable system. So I think we are super cost competitive. It's a really simple platform, and we know that we are cost competitive to more or less any on-land system.
Okay. If any of the other questions haven't been answered, Prashant, please feel free to reach out again. We'll be happy to share, just to make sure that we kind of respect everyone here. We'll set this as done. At which technology readiness level is the OHP now?
Yeah, we are ready to. We have installed it in Heraklion, and yeah,
it's ready.
It's ready. Yeah.
Thank you for the question. Aradhya Nagar, hello. I have a question regarding the maximum dimension of the platform that can withstand cyclonic waves and tides.
Johannes, before we go to this question, maybe the technical readiness level is we are ready, yeah. But you might, if you are Googling around, you might see many attempts for floating platforms, and you might see many pictures. Obviously, today we had some visions and some constructed pictures as well. But many of the other competitors, or I don't know if we can call them competitors, because there are none, as far as we know, have any solutions ready on the market for maritime environments. So that's unique. That's a unique solution worldwide, and we are the only ones who can provide these modular and platforms for multi-use. We are the only ones who can do that in the world.
So thank you for this addition, Philipp. So now we come back to the question Aradya had. I have a question regarding the maximum dimension of the platform that can withstand cyclonic waves and tides, because in a country like India, the cyclonic waves are very common during the monsoon season.
Cyclonic. This is, as we told earlier, this is strongly dependent on the precise location, how big you can go, and what waves you have there. Obviously, if you go to freak waves, you don't want to go to Portugal where they make the big wave contest. You would always choose to try to find locations where you don't have massive waves, but we are quite, as we come from wave power plants, that's the initial idea of SinPower, to produce electricity out of ocean waves. The whole platform is designed to survive in really strong and storm wave conditions.
Okay. Another question from Raul. What would be the total installed power kilowatt peak on a typical basic structure? So I don't know, typical basic structure. I don't know if you're referring to the smallest floating unit. Obviously, it wouldn't really make sense to build something that small. We would try to go bigger. What we know is that we can install hybrid systems of 5 megawatt peak and more if required. So the sky is really, or the ocean is the limit in this case. Giovanni Rinaldi, what are the O&M requirements of the device, and what is the maintenance philosophy for the project lifetime?
Yeah, besides what we have explained earlier, that all parts can be exchanged super easily, we have, as we have our Modtronics more or less distributed all over the platform in many small parts, many small electrical parts build the whole network. All these electrical parts are computer controlled and have sensors inside. They have sensors for temperatures, they have sensors for the production of electricity, etc., and we can read them. So if we see any change in these sensors, we can have a predictive maintenance approach. So before, and we have a larger breakdown, we can already go there and repair stuff.
All right. Can you explain the importance, from Dominik Schnabila, sorry, Greenway Energy AG, great technology. Can you explain again the importance of combining the OHP with electricity storages, and what storage technologies did you consider apart from the presented ones?
At the moment, we only store in supercapacitors. That's the peak shaving capacitors on demand, on the demand side and on the supply side. That's this super fast fluctuating power peaks which you have in smart grids and electrical networks. When you don't connect to a large network as we have it in Germany, this comes to problems. And on the other side, we have lithium ferrite storage, which is super compact and high density storage. What we don't have yet is any liquid storage or thermal storage or anything else.
But obviously, we could use the electricity produced or the energy produced to produce H2, for example, or any other type of power to X application is possible with our technology. However, we would only go until the connection point to this technology.
Yeah, we are open for people who want to integrate their solutions. So when you go to a liquid storage system, for instance, we could use our piping systems as liquid tanks because they are really chemical resistant solutions. And we have a closed piping system below and above water surface, which we use for installation and which we can use also for cooling. And obviously we could use it by the same way also for storing electrolyzer liquids. This is the question.
Okay. Well, it's a lot of questions and we're running a bit to the end of the time we have scheduled. I'll try to find something that hasn't been asked yet and might be of interest to everybody who's listening. What is your rollout strategy to countries like South Africa, Australia, from the time frame point of view?
Yeah, it depends on the demand side. I mean, we are here a fairly small company with a strong focus on research and development. In the past, we have a lot of academics here who have developed this high-tech solutions, and we are trying to cooperate with any given project. So we are open to deliver to any location in the world, but when it goes far, we obviously want to do that with local partners.
Okay, let's see if we can answer maybe 2 more questions here, Philipp. Raul Cascajo said, the units should be designed for every sea. For example, it's not the same wavelength in the Mediterranean than in the North Sea.
Yeah, obvious.
Yeah, so the platform does this. We also have a solution for the wave energy production to customize this with regards to the wave climate that you're in. The powertrains that we showed you before, we can install them in a different number of stacks, reaching from 4, 8 to 12, which increases the amount of power. So in a more moderate wave climate, we would then obviously install less powertrains. And in a more strong wave climate, you could install more powertrains. So there's also a great deal of flexibility and customization according to the climate conditions.
I read my favorite question here. Flora Mitaku. Are you interested in working in smaller Greek islands? Yeah, obviously this is our home run in Greek. We have a lot of Greek employees and friends in Greece. We know Greece really well, and we have 2 projects actually in Greece at the moment, talking about the 3rd. And if there come more, it's obviously easier for us to supply these projects in Greece. And we are really happy to go for any larger or smaller islands there. I love Greece, and I'm really much looking forward to work here more and more. Levelized cost of energy. Yeah, okay, this is we can if we go in industrial scale solutions, we can go far below 10 cents per kilowatt hours. Obviously, this strongly depends on the location side, the levelized cost of energy. For the ones who come from this sector, this is a really important question. I can understand, but this is not there's not a single shot answer in this. The function of the power cubes. What's that? Maybe the powertrain is the function of the power. Okay. Yeah, this is the same principle. The power cube is the same principle as we connect the strings. It just allows to connect more pieces of the modules in a single place by plug and play without wiring them, because the strings obviously get long. The more modules you add on, the more power you can produce per string. But sometimes you reach a length which you don't want to handle anymore. That's why we have the power cubes. It's more breaking down this length into different pieces, and then you can connect power cube to power cube. So you make high power units of whatever you want, inverters, batteries, etc. How many years of warranties? Yeah, we are working together here on the warranty side with German insurance companies. This is also strongly dependent on the project itself, and we can give warranties to your projects if wanted. The platform. With energy source is the priority on the platforms. Which energy source is the priority on the platform? Yeah,
I mean, obviously, it really depends where you place the platform. As we initially said, if you go to, for example, the North Sea, you might put a larger focus on wind and wave energy. If you go into more equatorial climates, obviously, there's a lot more potential maybe for solar energy. So it's really dependent not only on the macro, but also on the micro location, might have a large impact on how much power you can extract from each energy source.
I think we have answered most of the questions. There are some repetitive questions here, which we don't want to answer again. Obviously, feel free to contact us directly. Johannes, we have stretched the time. We are still in time.
No, we are in time.
We are in time, I see. Still 5 minutes possibly to go, but nevertheless, I think we have taken a lot of your time. Thank you really much for listening. I hope it was interesting for you, for us. It's exciting. It's an exciting way we are going, and we see that there's a lot of music in this field of ocean energy, of this ocean hybrid platform. Even before this event, we have been approached all the time. Hopefully this increases now. Thank you really much to you. Stay healthy, and we are really much looking forward to work together with you in any cases.
So Philipp, thank you very much. From my side, I just wanted to add one last thing. We will be regularly hosting these types of webinars, obviously not always in combination with a new product reveal, but we will on a monthly basis go into webinars explaining certain aspects of our technology, also going a bit more into depth. If you want to receive updates and information on our technologies, on webinars, and what's happening at SinPower, please sign up to our newsletter. You can find the sign up form on our website. If this doesn't work for any case, my email address and the contact@sinpower.com email address are always monitored closely. And if you have any further inquiries, requirements, project ideas, please feel free to reach out, spread the word, share the information. We think that we really have a technology that will set a milestone in ocean-based energy production and infrastructure development. Thank you very much. Stay healthy. I wish you all a further good passage through the pandemic. Make sure to stay healthy, and all the best.
Goodbye.